This is the YouTube recording for Lesson 24 as presented on May 13th and 14th. We're going to start by doing some simplifying. We have inverse cosine of 3 pi over 2. Again, please remember that inverse cosine and cosine are opposite operations. Those cancel each other out, and whatever's inside the parentheses is going to be your answer simplified. Sine and inverse sine, even though they're in the opposite order, again, cancel each other out, and you're left with whatever is inside the parentheses. Cosecant and inverse sine of root 2 over 2 is our next one we're going to simplify. We're going to start on the inside, making sure we find inverse sine. We want to make sure that inverse sine is in our principal root. So we're going to find inverse sine of root 2 over 2. Sine is a y value. It's going to get us 2 pi over 4. Now we want to take cosecant of pi over 4, which is the reciprocal of that point. You're going to want to rationalize that and simplify. You get just root 2. The next one, we have tan of arc cosine of root 3 over 2. Again, we want to start on the inside brackets by finding arc cosine of root 3 over 2. Then you're going to find tangent of pi over 6, which is root 3 over 3. As we move on to some more complicated problems, again, we don't have to have these signs match. We have to be able to pay attention to if we're moving from the inside to the outside. So for this first one, again, you want to start on the inside of the brackets. So you're going to start by finding sine of negative pi over 6. Remember that 11 pi over 6 and negative pi over 6 are in the same position. Sine is the y value, so your answer is negative 1/2. Now we need to find inverse cosine of negative 1/2. Cosine is an x value, so we're going to find an x value in our principal root that is negative 1/2. And then we move to the inside to get our answer in radians, 2 pi over 3. Inverse sine of cosine of 5 pi over 4. Again, we're going to start with finding cosine of 5 pi over 4. Now we need to find inverse sine of negative root 2 over 2. Inverse sine is a y value, so we're going to find the y value in the principal root and work our way in. Again, we want to make sure, since we're using the principal root, that it is between negative pi over 2 and positive pi over 2. So our answer is negative pi over 4. Our last example on this page is inverse sine of tangent of 3 pi over 4. We want to start by finding tangent of 3 pi over 4. Again, tangent is y divided by x, which gets us to negative 1. Now we need to find inverse sine of negative 1. Again, sine is a y value, so we're going to find a y value of negative 1. And our answer is negative pi over 2. So today we're going to continue with that solving idea where we are taking inverse sine and arc sine interchangeably. We're going to again use the same rules that we talked about the other day, or same directions we talked about the other day. You're going to be asked to find the principal root or the primary root. You're going to ask to find all roots in one revolution. That means x is between 0 and 2 pi. And then you're going to be asked to find all real values. Here you need to make sure you're using k to represent all integer solutions. Again, that's going to be revolutions forward and backwards, giving us all values from negative infinity to positive infinity. So for the first one, we're going to find the radian measure in the principal root for cosine of theta equals root 3 over 2. Again, we want to start by isolating theta by taking inverse cosine of both sides. For cosine, your principal root is between 0 and pi. So we're looking on our unit circle at quadrant 1 and 2 for that interval between 0 and pi. Cosine is an x value, so we're looking for an x value in quadrant 1 or 2 that is equivalent to root 3 over 2. If we want to solve for all values in one revolution, again, we're changing our domain to now be one revolution around the unit circle, so we're looking at 0 to 2 pi. We still have that first answer of pi over 6, but then we find a second place where our x value is equivalent to root 3 over 2, and that gives us 11 pi over 6. If we want to change this to all real values, again, now we're changing our domain so that we're looking at all real values from negative infinity to positive infinity. Here we have pi over 6, and we're going to add 2 pi k to represent the fact that we want to go around the circle one time to get back to that second revolution, and the second and the third and the fourth time that this value happens. Again, think about the fact that this is a wave. So we want to start here at pi over 6, and we want to be able to come all the way back around to get to that next value and keep up with those rotations. For 11 pi over 6, we are down here in quadrant 4. Again, we want to be able to represent going all the way around the circle, infinite amount of times forward and backward so that we get all solutions. For our next one, we had this on our homework twice. When cotangent is undefined, we want to solve for x. Again, we want to start by figuring out, can we find what cotangent of x equals when it's undefined? And the answer is no, that's not on our unit circle. So we go back to the thought that when we get an undefined value, that means we're dividing by 0. So if we have an undefined value, we want to flip that fraction. So I'm going to flip and find the reciprocal of cotangent, which is tangent. And if something was undefined before, now it's 0. Again, we want to think about that when that value comes out as undefined is when we have a 0 in the bottom. So we're going to flip that to now know that tangent is 0. So if we're looking for the principal root, the domain for tangent is between negative pi over 2 and positive pi over 2. So we find on our unit circle where tangent of theta equals 0, and that is actually 0 radians. We want to find where tangent of 0 is in one revolution. Now we're changing our domain to go from 0 to 2 pi. There might be more than one place where tangent is equal to 0, and it's at 0 and pi. If we want to change those to all real numbers, we're going to have our answer of 0 plus pi k. Notice how that end is going to change when you look at where your solutions are. We have a solution at 0 and pi. Notice that those are exactly pi units apart. They're on the same spike, on the same, so my end changes to pi k. That distance between them is pi. I can get to the next value in the revolution. The next one is tangent of plus and minus 1. Again, we're going to start by doing the algebra to isolate our theta. So what we're looking for is where tangent of theta equals plus and minus 1. Inverse tangent plus and minus 1. For your principal root, that's going to happen twice. So we're looking at the region between, or the domain between negative pi over 2 and positive pi over 2. So theta is going to equal negative pi over 4 and positive pi over 4. Again, when you look at that sketch, it's going to be right in the middle of quadrant 1 and right in the middle of quadrant 4. If we change that domain to talk about one revolution, now we're looking at the domain between 0 and 2 pi. This is going to happen much more often. We still have quadrant 1, but now we're going to add in quadrant 2, which is going to be at 3 pi over 4. We're going to add in quadrant 3, which is 5 pi over 4. And then finally quadrant 4, which is 7 pi over 4. So if we do our little sketch to see where those are going to be, we have 1 at pi over 4, 1 at 3 pi over 4, 1 at 5 pi over 4, and 1 at 7 pi over 4. Notice 3 pi over 4 and 7 pi over 4 are on the same spike, same spot. They're exactly 180 degrees apart from each other. Notice that pi over 4 and 5 pi over 4, again, are on the same spike. They're exactly 180 degrees apart. So when we write out our answer for all real values, we're going to write the first one, which is pi over 4, and then we're going to put pi k, which accounts for the first one, and that 5 pi over 4. It's already in that interval. Next, we're going to write our second solution of 3 pi over 4 plus pi k. Again, we're listing the first solution, and 7 pi over 4 is part of that. Now there's actually a simpler way to write this problem. If we notice that these are actually exactly 90 degrees apart, we can actually combine those two into one statement and say pi over 4 plus pi over 2k. All right, now we're going to have a few more steps before we can actually isolate and find our values. Again, as we're working through these problems, we're just making our solving one step harder each time. So we're going to try and isolate that cosine of theta. First step is to subtract 3 from both sides. Again, our goal is to isolate the cosine theta. So next we're going to divide both sides by 4. Now we're going to isolate theta by taking inverse cosine of both sides. So if we're answering the question in terms of the principal root or the primary root, your answer is going to be between 0 and pi. So we're going to look in quadrant 2 for that negative x value of 1/2 and get an answer of 2 pi over 3. If we change that domain to be talking about 1 revolution, now we're going from 0 to 2 pi for our domain. There's going to be 2 places where it's equal to 1/2, negative 1/2. So we've got 2 pi over 3 as well as 4 pi over 3. Change that domain one more time. Again, we're making it just a little bit bigger each time. Now we're dealing with negative infinity to positive infinity. So we're going to write our answers of 2 pi over 3 plus 2 pi k and 4 pi over 3 plus 2 pi k. If we draw a sketch of what that looks like, we have 2 pi over 3 and 4 pi over 3. Again, notice those aren't symmetric around the unit circle, so we have to list each one separately with 1 full revolution to get back to the next place that happens. That's why we have the 2 pi. And again, remember k is representing all integer revolutions. Let's do one again. We're moving up just a little bit each time, making these equations just a little bit harder. This time we have 4 sine squared x equals 1. I'm going to start by isolating that sine squared. I'm going to divide both sides by 4. Then I'm going to take the square root of both sides. And remember, when you take a square root, you have to add in a plus and a minus. Now the square root of 1 is 1. Square root of 4 is 2, so that reduces to sine of x equals plus and minus 1/2. So x is going to equal inverse sine of plus and minus 1/2. We're going to find the answer in your principal root. We're looking at a domain from negative pi over 2 to positive pi over 2. So we're going to look for a y value that's 1/2 and negative 1/2. So our answers would be negative pi over 6 and positive pi over 6. If we now change that and look at all revolutions, or sorry, one revolution, we're looking at a domain from 0 to 2 pi. So it's still going to happen at pi over 6, that's quadrant 1. We're going to look in quadrant 2 for a y value of 1/2. Gives me 5 pi over 6. We're going to move into quadrant 3, and then we're going to go back to quadrant 4. Our answer is for all revolutions, again, now we're changing the domain, is pi over 6 plus pi k and 5 pi over 6 plus pi k. Again, as we draw the sketch of that, pi over 6 is in quadrant 1. And if we move 180 degrees, we'll get to quadrant 3. Again, on that same spike, that would get us to our 7 pi over 6. Those are exactly pi units apart. Looking at your second two answers, we had one in quadrant 2, which was 5 pi over 6. And then we had our last point in quadrant 4 at 11 pi over 6. Again, they're on the same spike. They're exactly pi units apart. So we can list one with the k at the end to get to the other one. So we don't have 4 separate solutions. We have 2 solutions. Let's look at one more. We have 4 cosine squared x minus 3 equals 0. Again, we have to isolate the x. So we're going to start by adding 3 to both sides. Then we divide both sides by 4. Now we're going to get rid of that square by taking the square root of both sides. Remember, if you take a square root, you have to add in your plus and your minus. Now I cannot reduce the square root of 3, but the square root of 4 is 2. Take the inverse cosine of both sides. So what we're looking for is inverse cosine of plus and minus root 3 over 2. If we're looking for, again, our principal root, the principal root for cosine is between 0 and pi. So we're going to find the two places where root 3 over 2 is both positive and negative. That's going to happen in quadrant 1 at pi over 6, and in quadrant 2 at 5 pi over 6. We want to add in one revolution. Again, now we're looking between 0 and 2 pi. So we're still going to have that first answer in quadrant 1. We're going to have that second answer in quadrant 2. Now we're going to add in a third value in quadrant 3 and a fourth value in quadrant 4. Change your domain one more time. So we're changing that domain to all real numbers. We're going to have pi over 6 plus pi k and 5 pi over 6 plus pi k. Again, when you graph those, your first position is at pi over 6. And we have a point exactly 180 degrees at 7 pi over 6. So we have them exactly pi units apart. Looking at your last diagram here, we're going to 5 pi over 6, which is in quadrant 2. It's going to be exactly across from 11 pi over 6. Same spike, they're exactly 180 degrees apart. So we have that ending of pi k. All right, this is the end of the lesson. At this point, you should be able to complete the exit task and work on your problems on Schoolology. The answers are posted on Schoolology, so you can double check your work.